In problem number 1, we're asked to figure out which is the explanatory variable. The explanatory variable explains the response. So the grade point average explains the academic performance the first year, so that would be B. In problem number 2, we want a positive association. So if we think about the slope, like we learned in algebra, it's the same thing. So when one variable gets larger, so does the other variable. So that would be A. In problem number 3, a correlation coefficient measures how close all the data points are to the prediction equation. A correlation could also be on a curve. In problem number 4, we have a scatter plot about outside temperature and stopping distance of a certain car going 40 miles an hour. If you look at the outside temperature, as the temperature increases, my stopping distance increases. This is an association. It doesn't mean that one is causing the other to change. It just means they're going together. So does this prove that one is actually causing the other? No, because we're not sure if the temperature is responsible for the stopping distance or is it some other variable. In problem 5, if we change the stopping distance to yards instead of feet, how will that change the correlation? We calculate the correlation by multiplying the z-scores of the x's times the z-scores of the y. Z-scores don't have any units. That means correlation doesn't have any unit either. And if I change from one score from feet to yards, it's not going to change the correlation. So the correlation will not change by changing the units. In problem number 6, we're going to add another data point at 0 degrees Celsius and stopping distance of 80 feet. When you look at the graph, you could see this is way far away from the rest of the data. Because it's far away from the data, it's going to weaken the correlation. So the correlation is going to go down because the new point is far away from the rest of the data. In problem 7, they're asking us about correlation, or which is true. It is between -1 and +1. On choice B, it says it's resistant, but that's not true because we're using the mean to calculate the correlation. The mean is not resistant, so the correlation is not resistant. So if you look at C, if we switch our variables between x and y and do y and x, it's still the same correlation. It doesn't change it. If I have a perfectly straight line, my correlation is +1. That's not true because it also could be -1. In problem number 8, we have a graph about carbon monoxide versus nitrogen oxide. And if you look at the graph, we have a prediction equation right here. That's our prediction equation. So they ask us to look at our least square regression line. And we want to know the predicted car that emits 2 grams of CO. So I'm going to look at 2 grams. I'm going to go up to the prediction equation, and I am going to go left, and I can see it is about 1.7. In problem number 9, look at our scatter plot. Here is my prediction equation. All the points under it have a negative residual. That means that my prediction equation predicted too much. Above the line, I have positive residuals. So look at this point. That's below the line, so I have a negative value for the residual. Now number 10, which is correct. The correlation is the slope. No, it is not. The correlation is how close they are to the prediction equation. Choice B, the square of the correlation is the slope. No, that's the coefficient of determination, so that is not correct. And choice C, the square of the correlation is the proportion to the line on the prediction. No, R square is the coefficient of determination. And D, the coefficient is our variability that explains or accounts. So that is the only one that is correct. On E, the sum of the squares of the residual is 0. No, the mean is 0. The sum doesn't have to be 0 because of rounding errors. So question 11 is asking about which of the statements are true about the residuals from the least square prediction line, which is true. They do all have to add up to 0. The plot of residual is useful to see if it is a good fit, because we're looking for no pattern. If it has a curve or a fan, not a good fit. So on question C, the residual minus the value of the predicted, that is the definition of residual. That would be true. An influential point is going to pull the equation toward it. It doesn't necessarily have the largest residual. So all of the above were true. In problem 12, we have a scatter plot about the length of the fish, the number of eggs they produce. Notice it's in thousands of eggs. So here's our prediction equation from the problem. So if I look at my computer printout, my constant, that would be my y-intercept. So here it is. And my slope would be the fish length. So here's my slope. So I could write this in two ways. I could write it, but I make sure, the first way I wrote it, I make sure I know that's in thousands. And if I don't write in thousands, then I can go ahead and write it that way. Either way is correct. When I answer the question, they're asking me about interpret the slope. So for each unit increase, the number of eggs increases by 39.25, but my increase would be in thousands, not in centimeters here. So A isn't correct, B and C aren't correct. D is giving me the answer for the y-intercept. So notice on E, it says the eggs 39,250 because in my problem, the original problem, it said in the thousands. In problem 13, they're asking the percent of variability that is explained by the least square regression line. That's the coefficient of determination, R squared. So the relationship between correlation coefficient is the square root of R squared. R is the correlation. So make sure you answer the question that's been asked. So that would be D. Question 14 is about a study of children watching television. And in the study it says the hours watched explain 25% of the observed variation of reading scores of 125 subjects. So because it said it explained the variation, that is the coefficient of determination. So that's why in this problem I took the square root of 0.25, which is 0.5 is the correlation, because they're asking what is the correlation. And as the TV viewing increased, the students had lower scores, So it's got to be a negative correlation. So that's how I got C for the answer. In question 15, we have a prediction equation about outside temperature and heating a house. So I have 1344 minus 19x. So they want us to interpret the slope. So when the temperature goes up 1 degree, what happens to the usage predicted by the regression line? Well, I have negative 19, so that means it's going to go down 19 cubic feet. On the free response question, we are asked to write a prediction equation. So notice in the problem it says that the fire damage is in thousands of dollars. So I look at my computer printout. My predictor, my constant is 10.25. That is my y-intercept. So in my prediction equation, I have 10.25 as my y-intercept. My slope is 4.92. So I have 4.92. I can do this problem in two ways. If I write my prediction equation as fire damage hat, and I put distance, that would be in context. If I use just y hat x, then I have to explain what x and y equal. The second part of the problem said interpret the slope in context of the equation. So my slope is 4.92. That's in thousands of dollars because that's what initially said in the problem. So for each additional mile between the fire station and resident, we predict a $4,920 additional damages. So in question B, the house is 3 miles from the fire station. It received $22,300 in damage. So that's the actual damage received. So I want to calculate and interpret my residual. So I'm going to use my prediction equation. I am going to plug in 3. So I got 25.04. So I'm going to calculate my residual. My residual is my observed minus predicted. So this is thousands of dollars. Notice I changed this to 22.3 because my prediction equation I wrote in thousands of dollars. So I got negative 2.74, so it over predicted the damage by that amount, 2,740. So in question C, I need to interpret the correlation coefficient. When I look at my computer printout, I don't have correlation coefficient on here. Wait, I do. I don't have correlation. Okay, here's R squared R squared is my coefficient of determination. So if that's my coefficient of determination, I am going to take the square root of that number. So 0.9325. If I take the square root of this number, I get my correlation. That's how I got 0.96, because this is R squared and this is R. So my correlation is 0.96. Because it is positive, because I have a positive number, and it's very close to 1. So it's either close to positive 1 or negative 1. So I have a linear relationship between the fire damage and the distance from the fire station.